Class 2 biosafety cabinets are the most commonly used engineering control in labs working with biological materials. A major advantage of working in these cabinets is that the working environment is protected from contamination by a constant downward flow of HEPA-filtered air. More importantly, a Class 2 BSC protects both the researcher and the surrounding area. There are other types of airflow cabinets, but they do not all provide the same type of protection. For example, chemical work should be conducted in a chemical fume hood. When in doubt, email EH&S for a risk assessment when working with an experiment that involves multiple hazards. Any installed BSC must be certified annually. Check the certification label on your unit to verify that it has been certified within the last year. Certification is always required if the cabinet is a new installation, has been moved, or undergone a major repair. When working in a BSC, your tasks fall into 3 phases: the preparation phase, the work phase, and the closeout phase. In the prep phase, you will prepare yourself and the cabinet for work. First, to prepare yourself, make sure you wash your hands. Hand washing protects both you and your experiments. Second, wear basic PPE when working in the biosafety cabinet. PPE not only protects the researcher, it can limit contamination from skin and clothes that can ruin an experiment. The level of PPE needed varies from lab to lab and from project to project. Be sure to check the PPE assessment before starting your work. Also, consult with environmental health and safety if you have any questions regarding your PPE. To prepare the BSC, toggle the UV light switch from UV to visible light. Turn on the blower and turn on the airflow alarm. Allow the blower to run for a minimum of 5 minutes. This is an important step to purge contaminated air that might settle while the cabinet is not running. After 5 minutes, wipe down the internal surfaces of the BSC with the appropriate disinfectant. In addition, sterile technique requires disinfecting items entering the cabinet. Wipe down bottles and flasks and stock the BSC with sterile equipment. This procedure should be developed based on the sterility needs of the experiment. As you continue to set up the BSC, do not overcrowd the workspace. Overcrowding can interrupt airflow, which can make the cabinet ineffective. Keep the air intake, which is the vent in the bottom of the sash underneath your elbows, clear of all items at all times. If this vent is blocked, it allows unfiltered air to enter the hood. This can contaminate the work and possibly endanger you. Also, keep items from directly blocking the vent in the back of the hood. Place all items that will be used in your procedure inside the BSC as far back as possible before beginning work. Work at a minimum of 4 inches inside the BSC. The middle section of the cabinet is the optimum work area. It is also useful to reference a list of all the items that you will need to conduct your work. Once the BSC is prepared, it's now time to work inside the cabinet. Enter the BSC with a forward motion, avoiding any side-to-side sweeping motions. Wait approximately 1 minute to allow the cabinet to stabilize before starting work. It is important to minimize movement in and out of the BSC to maintain the protective barrier of the cabinet. Always keep the front sash in the lower position when working. Set up your workspace from clean to dirty. The goal is to not cross over clean items with potentially contaminated materials. If aseptic technique or sterile technique is needed, there are several further steps you should take. Use sterile reagents and media and work to keep them that way. When you pipette, do not allow the pipette to touch anything non-sterile. Conversely, do not allow contaminated pipettes to touch clean surfaces. To maintain sterility, remove liquid from containers at an angle. Keep bottles, flasks, and tubes covered as consistently as possible. Contamination from the hands can blow into the containers. Remember that it is the inside of the containers that is sterile. Treat the outside as dirty and clean with an appropriate disinfectant. Each pipette should be used once and then either discarded or disinfected if it is a glass pipette. If you spill anything in the hood, clean up the spill immediately to prevent cross-contamination. Stop what you are doing, cover the spill, treat with an appropriate disinfectant, and wipe up the spill. Maintaining sterile technique throughout your work in the cabinet will help your experimental results. Once the work is complete, you will need to return the cabinet to its initial clean and empty state. This is the closeout phase. First, remove contaminated gloves and put on a clean pair. Decontaminate the surface of all containers and equipment before removing them from the cabinet. Nothing should be left or stored in the biosafety cabinet after completion of work. Close off your bio waste bag and place it into the bio waste stream. Perform a final surface decontamination of the workspace, sides and back, and the interior glass surface. Remember, if you have used any type of biological material in the BSC, then all surfaces need to be decontaminated with a disinfectant appropriate for the materials used. For the BSC itself, shut the sash, turn the alarm and the blower off, and toggle the switch from visible light to UV light. The cabinet is now ready for the next researcher to use it. Finally, always remember to wash your hands after you have removed your gloves. Protect your experiment from contamination by using a biosafety cabinet. Remember to prepare yourself and the cabinet for work. Use aseptic techniques when working in the cabinet. And properly close out the BSC when you're finished. By using the cabinet correctly, you minimize the chance for contamination to interfere with your protocol. Please consult with your biosafety officer to review your protocol, practices, and any questions you may have. Thank you for watching.